So today, I hope we have enough material to go the whole time. It's all up to you. So I've got all of the homeworks loaded in here, so we can go through every one of them. So if you have any questions, we can look them up, and we can discuss the homeworks. The tests are going to be on. The test is going to be on the homeworks. Do well on this test, and if you're happy with your grade, you don't have to take the final. So official policy. If you do take the final, it can hurt or help. So it's going to be averaged in. You'll have 4 exams averaged into your exam average instead of 3. So it'll be equally weighted with the others. All right, so ball's in your court. Yes. Okay. Number 13. Ah, yes. Okay. So what is your specific question? I'm going to try to drill down too, and get an idea of what's tripping you up. Okay. Okay. So this was the video lecture on the color transformation. Okay. So you understand the XYZ values. These are. Let's see. Where's my mouse? Okay. So this is X, Y, and Z right here. So X, Y, Z. You got that part, right? And we're looking for the standard RGB values, but we also want the 8-bit part. So these are 2 different parts, okay? So the standard RGB values are sRGB. So if you go to the color notes, you'll find this matrix here. So I went ahead and added this in to the notes. So this is the transformation matrix from XYZ to standard RGB. Okay. Now, this is just another review of matrix multiplication. We don't make you take linear algebra in our chemistry curriculum, but we do use a little bit of linear algebra. And this matrix algebra is a linear algebra. Okay. And so the way the matrices work is this is the transformation matrix, and it's left multiplied to the XYZ values. So the X value is 0.7, the Y value is 0.64, and the Z value is 0.09. So that's our XYZ values. The way this works is that you take this row and you multiply by this column, okay, and add it together. So this first number, the R number, the standard red number is 3.2. I'm just going to abbreviate it to 3.2 times 0.7 plus a minus 1.5 times 0.64 plus a negative 0.5 times 0.09. Okay. So pull out your calculator. Enter 0.7 times 1.5, enter 0.64 times minus, and 0.5, enter 0.09 times minus. 1.23. Okay, so 1.2. Then the SG is equal to a minus 0.97 times 0.7 plus a 1.8 or 1.9 times a 0.64. You see how it's now the second row times that column added together gives you the second row number, okay? And then plus a 0.04 times a 0.09. All right. So 0.7 enter 0.97 times, and then 1.9 enter 0.64 times plus, and 0.04 enter 0.09 times plus. 0.54. And then SB. This is a 0.06 times a 0.7 plus a negative 0.2 times a 0.64 plus a 1.1 times a 0.09. Okay, so 0.06 enter 0.7 times 0.64 enter 0.2 times minus 1.1 enter 0.09 times plus. So 0.013. All right, so these are the sRGB values. They don't look anything like the numbers in the answers because I now need to convert them to 8-bit. And so I take those values. So I have 1.2, 0.54, and 0.013 as my sRGB values. And I multiply them by 255. So I get 3, and then 0.54 enter 255 times 138, and then 1.2 I get 306, but this is going to be capped at 255. If you go through those notes, you know that these 8-bit values are going to be capped at 255, and if you have any negative ones, they're capped at 0. So they've got to be between 0 and 255. And so this one, since it's over 255, we're just going to stop that one at 255. And so what's the closest number to this one? It would be the 255, 135, 1. And so that's where we get this value here. So that's a long problem, and I'm comfortable giving you a long problem for the homework. So just to reinforce the longer pieces. I typically don't give the longer values or the longer problems on tests because I want people to finish. There'll be 50 questions. There'll be 2 points apiece. Okay. But anyway, I wanted you to go through one more time on the homework a matrix multiplication so that you could reinforce that skill as part of being a chemist. Okay. We did it in the lab, in the PChem lab, we did that in Excel, so it did the matrix multiplication, but here and we review it one more time in Forensic Chem just to get you to do it by hand so you know that it's row times column added together. That's matrix multiplication. Now, could we, if we're pressed for time, what could we do? Well, look at this. This is big, big, and small. Okay, so look at this one. That's not small. So we know it's not this answer. Okay, it could possibly be this one. This one's over 255, so we know it's not that answer. So I've reduced it just by knowing something about X, Y, Z, and RGB. The X is kind of the red value, the Y is the G value, and the Z is the blue value. There's some overlap. That's what these off diagonal elements kind of mix the X and Y's and Z's a little bit. Okay, but in general, the X is the R, the Y is the G, and the Z is the blue. Okay, so if I've got a small blue value, then it's going to have to be one of these with a small blue value. Okay, this one that can't go over 255, so it's not that one. And so I really do need to do, for the homework, I really do need to do the math to determine whether both of them are big enough to be above 1, which means it would be above 255, or I'd have a situation like this. And so I'd have to do the math to determine between those two. So, okay, now let's look at the tristimulus values. And this is just taking let's see, so this chromaticity coordinate here, turning the tristimulus values into the chromaticity coordinate. So this is little x, and I'll just draw the equation for x. So that's x on top and the sum of x plus y plus z. Okay, so that's the little x value, and the little y value is the y on top divided by the sum of those three. Okay, so let's go ahead and add these three together. So 0.7, 0.64, add, and 0.09. So that's 1.43. So 1.43. And for the x value, let me enter that a few times. I've got 0.7. Enter. I'm going to swap them around. Let's see. Let's go down. Okay. Swap. Divide. 0.49. Okay. It's again 0.7 is half of 1.4. So we've got 49. So we know it's not this one. We know it's not this one. We know it's not that one. So we've already, just with the first one, reduced it down to C. But let's go ahead and check our work. 0.64. And I'm going to 0.45. Yeah. So 0.64 divided by 1.43 gives us 4.5. So we've checked both of those numbers, and so we know it's C. So those are the two color coordinate type values done by hand. Okay. So this will be a video you can go back and look at if you want. Okay, next question. There weren't really a lot of figures on this, but what if I gave you a chromaticity coordinate diagram? So the chromaticity coordinate diagram has, you know, little x and little y on here, and it's got that strange shape with all the colors on it. You know, and it goes from like red to blue all the way around. And so, you know, if we're given this 0.49 and 0.45, you would just go right here to 0.49 and 45, and you'd find that spot on that diagram and tell me what color it was. So, you know, I think that's fair game. If I gave you that diagram and you calculated little x and little y, you could tell me what color it was, and that would be a legit question. I'm looking for questions that I can ask that you can demonstrate your skill in a quick manner, and that would be one. So if you see that diagram and you're like, well, that wasn't on the homework, it's still the same concept. Show you the chromaticity diagram, give you the coordinates, say what color is this substance. Totally legit question and pretty easy. Okay. So if you see something new like that, don't freak out. Think, okay, what do I know about this topic? See if I can figure it out. Okay. Yes.
On the homework 11 question,
Mm-hmm.
I know it's 8, but I was just confused on why
Okay, yeah. So this one, the full metal jacket is the full metal around the bullet. So both of these have a completely closed top, whereas this has an open top. It's got some sort of bead in there to help with the expansion, and then these are completely hollow. So these top two, the C and D, are hollow points. B is kind of a hollow point, but it's assisted with this plastic bead. Okay, so that's why it's just A and E are the only ones that have full metal jacket around the lead bullet.
So let's say we get a test question. We get a question like that, you just got to know that it's not a hollow point.
Yeah, that's right. It's just yeah, it's not a hollow point. So if you see metal all the way around, so what if you like see the discoloration in these hollow points? That's lead. So that's a lead bullet. You can actually see the lead in a hollow point, most of them. Okay. Some of them have the plastic insert so that it helps with expansion. The plastic crushes and then the metal breaks apart in fragments and delivers the energy of the bullet into whatever it's been shot into. So, I mean, it's a, you know, people People have varying responses to bullets. I mean, they're my value of life. It bothers me to design bullets so that all the energy is delivered into the person you're shooting. But that's what they're designed to do. They're designed to kill. Now, when would that be appropriate? Okay, you've got somebody on a plane and you got an air marshal and they want to shoot this person in a tube with a lot of innocent people. Okay, you don't want a hollow point. It's going to go through that individual and hit somebody else or knock a hole in the wall. So, I mean, yeah, it's a dramatic situation, but it delivers all the energy of that bullet into the first person it goes into and not anybody behind that person. So, in that situation, I'd be a great fan of hollow points. And in general, I mean, thinking about it, yeah, I think that's a good thing. If that person is being repelled with lethal force, you want it to only impact that single person, or and not go through that person to impact someone else. Yes. No, I don't think we need to get into that specific situation, but yeah. So those rifle rounds have that expanded powder uh, area so that it can get a higher velocity. Because what's the energy equation? This is really another test, but it's a good question. What's the energy equation for projectiles? Kinetic energy. 1/2, yeah. So E kinetic. 1/2. We got that part. M and velocity's in there. Squared, yeah. Well, where'd the V go? Okay, so again, you can have a heavier bullet deliver more energy, or you can have a faster bullet deliver more energy. Okay, or you can have both, like the 50 BMG. Okay, it's just tall and a big old massive bullet and a whole lot of powder. And anyway, saw a great video of a guy shooting a steel plate with one of those. I don't know. He had a pretty decent range on it. He shot it and it was perfectly lined up, like straight at him. The bullet bounced off and knocked his earmuffs off. He was like a few inches away of death from ricochet. Yeah. He's like laying on the table. He's like, boom, and it goes, ping, and the earmuffs go off. And he's like, I'm done. Everybody in the group was like, yeah, we're not shooting that plate anymore. And so it just, that plate was thick enough. It just acted like a spring and just threw that bullet right back at him. Yeah. Of course, it was deformed, but still, a big piece of lead came right back at him and knocked his earmuffs off. So that's pretty scary. I don't watch a lot of shooting videos, but when I do, they're pretty amazing.
I saw this one video of this guy shooting off double barrel, right? He goes like, all right, this is what happens whenever you saw off the barrel.
Okay. Yeah.
It's like he shot. He says, "Oh, before you do anything, exactly." He like, "Make sure you watch your thumb so that way you don't blow it off." And I'm like, "Dude, why would you do that?"
Yeah, like that. Was that short? Like he could have his thumb over the end of the barrel?
Yeah.
Oh my gosh, that's pretty short.
I mean, all 10 fingers.
Yeah, that's right. Yes. Sorry. Yeah, but this is the physical properties part. So we really don't have any structures. We have things like bullets, or we have the pollen. Yeah. Oh, the polymer structures. Yeah, those. Yeah, for sure. So I'm surprised I didn't have the structure pictures on here. But yeah, that's right. I like, which one is styrene, which one is, vinyl chloride. So learn those structures for recognition. Yeah. Yes. Oh, wait a second. You raise your hand first. 9 on 11. Okay. Okay, Glazer style frangible bullet. So this is that Glazer style. Glazer was the manufacturer of this image. Yeah, so that's that. It's more than just a hollow point. It has that extra plastic tip to help drive expansion of the hollow point. Yeah. Yes.
I was going to ask on the topic of running structures, are we expected to know the plasticizers and stabilizers from the bench out every evening?
What? You think so? Are you asking for it? I didn't quite hear you.
I was just thinking of jokes.
Okay. Yeah, sure. No, what I'm thinking of is, could you look at, like, if I threw one of those plasticizers into all of the monomers and stuff, would you be able to recognize that it's not really a suitable monomer? You think about them, they have like aromatic rings and so on, but there's really no double bond. It's got some other things here. Maybe it has a, carbonyl or something like that, and some chains that stick off. But I don't see any place where it could polymerize. You know what I'm saying? So if I threw that in there, I don't think that should throw you off. And so, you might have I like to have 5 structures because it's A, B, C, D, E, right? And if one of those is a plasticizer, then I could ask questions about it. Which of those is a plasticizer? And you look at it and you go, well, that's the one that has the nitrogen oxygen thing, and I don't see any double bonds for a monomer, so I'm going to go with that one as the plasticizer. Is that legitimate? Yeah, I mean, I think that's a good thing I could do, and that way we could ask some questions about plasticizers. And let me ask you this question: what does a plasticizer do in the polymer? Keeps it soft and flexible. Yeah, think about makes it plastic. It's a plasticizer. It keeps it plastic instead of glassy. Keeps it from crystallizing. What does a stabilizer do? Scavenges what? Yes, scavenges free radicals, and that keeps it fresh. So you're both right. It's just saying it different ways. Yeah. So where do the free radicals come from in our daily life? Sunshine. Yeah. So same on us too. That's where we take antioxidants, right? We're getting blasted, and you take antioxidants to keep your skin fresh and your body from being insulted by the, if you get UV and it ionizes your body, then the free radicals, the vitamin E, vitamin C, those things, if you keep those by taking a multivitamin or whatever, then you'll protect yourself against damage from the sun to some degree. And what is lotion? Plasticizer. So, are we covered in a polymer? Yeah, protein. So we're trying to keep our plastic coating, not really plastic, protein coating flexible. Yeah. Fun. Okay. Yes, like the indicators that we used to think were arson. I talked about that. I think there's a homework problem about that, like crazed concrete, melted bed springs. What is it? The glass one. It was crazed glass and spalled concrete. Yeah, and burning on the floor. So burning on the floor is. Let's see, what features are normally considered indicators of arson but are not now? Okay. Select all that apply. Well, I've got spalled concrete listed. Yeah, so I think, it really, all of them. I mean, I don't know. I need to go in and like change the answer for that one, because if these were all in that report that said they used to be arson indicators, but now they've been seen in regular house fires that were not arson. But this one still is an indicator of arson in some situations, like the kitchen fire that video showed. There was burning on the floor, and the kitchen wasn't completely consumed, so it looked like there was a fire that was started on the floor. So I guess that one's sort of a maybe. So maybe I need to regrade that question. So I'll look at that. Okay. So what question was there? Someone had. Oh, spalled concrete. So you can actually ruin your concrete this way and spall your own concrete without heat. But so this is a concrete surface. So think of a sidewalk. Okay. And I did this in my house in Canyon, totally stupid. They said don't put salt on your sidewalks when it freezes because you'll screw up the concrete. And I was like, what can tiny little salt do to concrete? Concrete, right? Well, no, it totally soaked into the concrete. And then the next time it froze, it popped the concrete off. And so all of this surface popped off and left a really rough surface. So you've seen concrete sidewalks that are spalled where, the real smooth surface is gone and it's real rough underneath. It's just popped loose. And heat can do that too. If there's any moisture in the concrete, if it's hot enough, it'll pop the surface of that concrete off and you have that spalling effect. And they used to think that only happened in extreme heat. It's not so much the heat, it's the burn rate. And so if you have an accelerant, somebody puts gasoline on a concrete floor or whatever, and then it's maybe even an oxidizing agent, then that generates a faster burning rate and raises the temperature, and then the concrete can be damaged. But they found that in those Oakland fires, which were clearly not arson, and they still found spalled concrete, melted bed springs, crazed glass. And so, yeah, that's right. So they had to reevaluate their arson investigation. Let me turn my phone off. I keep getting interrupted. So. All my friends have found their phones. Okay. Okay. And crazed glass is when it shatters in a million little chunks, but doesn't necessarily fall apart. So a lot of glass windows have a polymer anti-reflective coating that kind of holds it together, and so it'll crack, but it won't fall apart. Your windshields, car windshields, are that way. Yes, I'm going to try to get it up to 50. I'm going to have to add a bunch of little tiny questions about all these materials. So be ready for some questions you've never seen before, but there's the same concepts. And so be testing your figure it out skills a little bit. I just like lots of questions that are low point value. Yeah. Yes.
Quiz 13, question 11. How do you figure out the answer? Okay. Like, what's your thought process?
Okay, so let's try to figure out. Let's see, which one again? 11.
Yeah.
Okay, so let's come up with a list. First of all, you need to know this. This is our spectrum. So what is the range of nanometers, the wavelengths of a visible spectrum? So what's the far left, the lowest, shortest wavelength? So this should be very familiar. This should be as familiar, like the electromagnetic spectrum in the visible region should be very familiar to you, like as familiar as your apartment or your way home. Okay. I hope you're not one of these people that has to use Google Maps to get home. Okay. Right? So what's the short wavelength then? Nanometer wise. You can guess. We get us close. Most people guess, we'll figure out. 200. Okay, so 200 is a little too low. That's the UV area. The water cutoff is at around 193, so 200 would be a good UV water cutoff. But so it's longer than 200. What's that? 350?
400.
Yeah, it's 350 to 400, but probably 400 is a good number to remember. So we'll say 400. It's a nice round number. So we'll say 400 is the blue cutoff of the electromagnetic spectrum. Where does our eye kind of peter out in terms of seeing light? 800, yeah. And so I always have just put 700 down. That's what, so if I was going to draw this, I go to 700. 800, I don't know that I can see. A lot of your detectors go out to 950, and that's in the near infrared. So when we're talking about seeing through the writing, remember that, the obliterated writing and seeing through it, some of the camera elements and sensors go out to 950. If you put a filter that blocks the visible light, then the only thing that camera can really use to develop its image is the near infrared, and it'll see through a lot of these inks and paints. So 400 to 700. Okay, so this is the blue end. So this is blue, and this is red. Uh-oh. It's okay. You all right? Okay, so now what about in between? So here we have, I'm going to draw a couple of numbers here. I'm going to say right here, 532, very, very specific. 532 nanometers, and I'm going to do 590 or 589, but I will say 590. So what's magic about those two numbers? Like, why would those be easy to remember? What is 532 nanometer like? Does that ring a bell? This isn't something we've like hammered home in our curriculum, but you've bumped into that wavelength a bunch of times. And why am I so specific with that wavelength? What am I probably describing if I'm going to be that specific with a wavelength? A what? Yeah, we're going through the RGB, but I'm giving you a couple of wavelengths that you can just memorize in your head to help figure out where the colors are. Because we're getting to your question about how did I know that this 530 nanometer beam was green? Okay, so I'm trying to answer that question. So I want to think about 532. What is 532 nanometer light? What does it come from? It's a very common source. Okay, I see in blanks. It's the neodymium YAG laser. It's the green diode laser that we have in our Raman spectrometer and in a lot of green laser pointers. It's a deep green. You've seen that green. The green laser pointer, the green Raman laser that I brought to class. Remember that green color. That's 532 nanometers. So whenever you think of green, think 532 nanometers. That's the wavelength for that laser, for the laser pointers, if they're neodymium YAG laser pointers, but they produce so much of that crystal that it's cheap. And so that's probably the wavelength of those green laser pointers. Why pick something different when it's really not any better? You're just spending more money on a rarer crystal, whereas they produce so much of the neodymium YAG crystal that that's probably what those laser pointers are. So this is green right here. Okay, and that's that. And I'll go ahead and write out the neodymium. So that's ND. YAG. So that we're getting a lot of, so neodymium, that's from the periodic table. Let's see, where is it? It's element number 60. So you have cerium, praseodymium, and neodymium. So ND, so that's neodymium. What is Y? Y is over here under scandium, and beside strontium, that's yttrium. So YTTRIUM, I think is how you spell it. And then this right here is aluminum garnet. So it's an aluminum garnet crystal. So garnet tells you the kind of crystal structure it is. It's made with the aluminum oxide, and then they dope in yttrium. So it's a yttrium aluminum garnet crystal, and then they dope in a little bit of neodymium, and neodymium is what we're using to get the green color. Okay. Now, why 590? What do we know that's at 589 and 589.6? Two very sharp lines. Yellow color. So what element gives a yellow color, really bright lines? As a chemist, you should know this. Sulfur, interesting. Now sulfur is yellow colored, but I don't know what its atomic emission is. This one is abundant in your drinking water. So like if you do a flame test of drinking water, you do DI water, you don't see much. You do tap water, yellow flame. Okay. Sodium. Yeah, so sodium. The street lights, those old street lights that are yellow, that's the yellow color of sodium. So when you think of yellow, it's 590. Very close to 530, but it goes from green to yellow right away. And then once you get between yellow to red, there's orange in there somewhere. So 600 to 650 might be yellow, and then one beyond that's red. So we have our sodium. This is yellow. Okay, orange and red. So Roy G. Biv, ROYGB. I guess IV is over here. Okay, but so we're looking at this at 530, very close to 532. That's going to be a green flashlight color, green laser.
So what you just said about 600 why would 12 right there?
12, okay. So an edge wavelength of 600. Okay, so the edge wavelength, and it's a low pass. So it's coming through here, and it's blocking the green, blocking the sodium, and it's blocking. So let's say orange is at 600. It's blocking the orange and passing the red. So we're only getting half the orange. We're getting all the red, and so I would say that's red. Yeah. If I want to get the orange, I need to have something that's like a edge wavelength of 590. So I would get all the orange and all the red. Yeah. If I have a filter that blocks at 540 or 550, I'm blocking the green and I'm getting the yellow, orange, and red, but my eye is going to see that yellow light and respond and say, it's yellow. So we kind of get, if we only get the red, it's red. If we get the red and the orange, it's orange. If we get the red, orange, and yellow, it's yellow. Okay, so do you see how that works? That's kind of confusing, but the eye responds to those shorter wavelengths. If I can see the yellow, then my brain says, it's yellow, even though I'm also getting orange and red light. And there's those I've got a couple of here they are. Yeah, so here's the filter. This is what type of filter. Well, you can kind of see it's text. What if I erased all this text on the test? Could you still do it? Just looking at this line right there. We're looking at the y-axis is transmission. This is the light that's going through the filter. This is 100% transmission. So if I erased all the words on this thing, so if I got rid of this and I got rid of this, you should be able to look at this line and tell what's going on. So this is the actual spectral line. Notice it's up here. It's a high value here, so it's transmitting this light, and it's a low value here, so it's rejecting that light or absorbing that light. And so we're not getting any of the orange, we're not getting any of the red or the green, we're only getting the blue. And so this would be a blue filter, so that's this answer. And it's the short wavelengths, so it's a short pass filter. What's the another name I could, like this is how I'd make the test. I look at this and I say, okay, short pass, I'm going to take that out and I'm going to put in another word that means the same thing, and I'm going to put that question on the test. So what's the other name I could use for this filter? High pass. So that's part of your skill, right? You guys, this is your fourth year. You got to figure out how lazy professors change multiple choice questions to make the exam. You know, the poor student does the homework and is focused on which is the right letter. Okay, and so they got the right letter, so they know it. No, you don't know it. You just know which right letter. Looking at this and saying, okay, this answer for this question is short pass. I don't see high pass anywhere on here. I bet if I were to change this question, I would change short pass to high pass, or I would change long pass to low pass. You know, I would be thinking about, okay, how can I understand all four of these terms, and what would I change about the text to make one of these other words the right answer? You know, how would I change this figure to make band pass the right answer? Well, this dark line would have to come back down. Okay. And so if that line came back down, then it's a band pass filter, because it's only passing a band of light right there. So then that would be a band pass filter. So do you see how to study? Don't focus on just the letter. Oh, I got it right. Okay. No, you didn't get it right. If you don't understand why it's right, then you really didn't get it right philosophically. Okay. Got a little bit of organic type nomenclature going on here. We got the vinyl part, we got chloro. So again, we're looking at this. We know this is polyvinyl chloride, and so that's the vinyl part, the chloride part. There's no chlorine in PTFE. That's polytetrafluoroethylene. Kevlar is an aromatic ring and amide linkages. So if I wanted to use a generic, like, how would I change this so that Kevlar was the right answer? I would do a polyaramid. That's kind of a weird M. So aromatic amides, that's a Kevlar type polymer. Okay. And then just polyolefin. I mean, it's just a hydrocarbon with double bond, because we're just using that olefin term. So no chloro, no amide, no ester. So it's just plain old HD polyethylene, high density polyethylene. How would I change this and still have the same question? So it's very similar to the homework, but it's a different question. I might put an LDPE here, right? So it's exactly the same question, but I just changed one letter from HDPE to LDPE. Okay. And the student comes and says, I've never seen this question before. That's just a little joke. Yeah. I get it. It's frustrating when you study the homework, you get to the test, and the question is so different. You're like, I don't see how this is the same. And I'm looking at it as like, it's the same concept, but it's totally different wording, totally different answers. Yeah, so there's that constant disconnect between professors and students. I do try to pitch the ball where you can catch it. You just got the joke?
She said my mom usually makes her lunch. And she sent me a picture of her holding a bag with just white powder in it. She says, I guess I'm having Coke for lunch.
Oh, gosh.
I'm just like, what's your problem?
Yeah, tell her, no, don't do it. Yeah.
I'm concerned. I don't even know what it is at this point.
Yeah. Suspicious white powder. What other questions do you have? Ask me anything. What percentage of your take-home pay should be used for a house or apartment?
That's a very valid question.
That's right. No more than 35%.
Right.
Otherwise, you'll be what's called considered house poor. You don't have enough to pay your bills and things like that. Yeah. Mm-hmm. Let me see what you're talking about. Let me pull up the lecture. That's the polymer one? Synthetic polymers? Okay. Like this? Is this the one you're talking about? Okay. Let's see how I can change this over. Let's see. Which one? Sure. Yeah. Okay. There we go. I'm just making sure the video follows what we're talking about. Okay. So what was the question? I got to where you were looking. Yeah, so like I will pick 5 of these structures, or maybe 4 of these structures in a plasticizer or something like that, and then put those up with A, B, C, and D, and then you'll say, okay, that's styrene or that's Kevlar or whatever, yeah, or PTFE. That way you kind of connect it to the structure and not just memorizing the names. Yeah. So I'm just going to focus on the monomers. Yeah. So yeah, the repeating unit, just again, you're just taking that and breaking the bond out so that it's, repeated. Yeah. Yes.
And you said the monomer name is just the same as the polymer.
That's right. Yeah. So that's what's so weird. Like propylene, if you look at the polypropylene, the actual polymer, there's no more enes. So it's kind of confusing in that respect. So that's the name of the monomer. This is propylene here, and so we've just made it poly by polymerizing it. Yeah. Yeah. And I mean, some of these are pretty complicated, so I don't know. Do your best. Okay. But like, I'm not sure if I looked at this one, like the difference between polymethyl methacrylate and polyvinyl acetate, I would have to scratch my head on that one, because it's just the esters flipped, right? And so, I'm more interested in knowing which one's Teflon, the nitrile piece, styrene is important, polyvinyl chloride. I mean, these are more common polymers. Yeah. So I would say for sure this page right here. And then the Kevlar one, I like Kevlar. And I really like this this illustration of those hydrogen bonds, because that's what's so important to its strength. We had Kevlar straps, these parachute straps that we tested at my last job, and they had a mechanical properties testing equipment. It's called an Instron, and it's just a giant thing that you could bolt your material in and pull on it until it breaks. Okay, and they put these little extensometers on it, these little arms, so they could measure how far it stretches, and then when it breaks, the little clips pop off, and so you can see the break. But you can see how much force it takes to pull and how far it stretches before it breaks. It's a great mechanical properties thing. We don't do that in chemistry because we're not engineers, but I was sitting there working with the engineers going, this is a cool piece of equipment. they had these straps of braided Kevlar that they would pull on, and it sounded like a shotgun when it finally broke. I mean, it would pull so tightly, and all those little fibers are slipping past each other, and you're working against the hydrogen bonds and everything, and all of a sudden, pow, it would break and pop loose. So it was really a cool piece of equipment. It also could push on things too. You could do compressive strength. And we worked with explosives there, and so they would do the compressive strength of explosives and the tensile strength of explosives, and it was a remote operation. So you put the explosives in there, set your tensiometers, and then you go into the other room and hit go and hope nothing blew up. So it was fantastic. Okay, now the person who's waiting for everybody to be done and then turn off the video, and then you come up here and you have like 3 more questions. Ask them now, please, so we can get them on video for your peers and for yourself, so you can go back and review it. Because I know some people are shy and they're not going to raise their hand and ask a question. So this is your chance. Okay. Nylon 66. Okay, so the 6 part is important. So nylon 66. So this, because there's 2 numbers there, you've got the hexylamine. So CH2, and there's 6 of those. Okay, and so then NH. And so we're gonna put a little bracket there. And this is going to be bonded to adipic acid, which has 6 carbons in it. So a carbon here, CH2. Now, how many of those are there? Well, I've used up a carbon for the acid on this side, and I'm going to use up a carbon for the acid on this side. Okay. So we're going to put the bracket right there. Okay. And so this amide linkage was made by hexylamine and this adipic acid. And so how many CH2s do I have to come up with the number 6? I've got 2 acid groups. It's not that hard. 4, thank you. Okay, 4 of those. So don't fall into the trap of thinking it's 6 here and 6 there. Okay, it's 4 over here because it's a diacid and we have 2 carbons on the acid pieces. So that's nylon 6,6. And it's just multiplied n times. So, and it's an AB polymer, AB, 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 because the A and the B have to react with each other to make the polymer. So it's an alternating polymer. So that's another term for nylon 6,6, classified as an alternating polymer, not a random polymer, not a block polymer. So it's an alternating polymer. Yeah.
Would it be alternating and addition?
An addition polymer, yeah. So addition. So we're doing we're adding those 2 groups. It would say also a condensation reaction. So when we react an acid with an amine, the OH of the acid and the H off the amine form water, and then they step growth addition. So we're adding these molecules on the end.
So do you have a test question like that? Will I have one of those stages?
Yeah, so like let's say I have this structure up here, and I say which one of these is nylon 6,6. So that's an obvious question. It's like which one of these polymers is structures is the result of a condensation reaction. Okay, and you say okay, yeah. In order to make it an amide, I got to have an acid and an amine, and I got to lose water. So that's a condensation polymerization step. Now I can't say that that these up here, I mean, these double bonds in their reaction, that they can be propagated 3 different ways. It could be free radical polymerization, it could be a cation mediated reaction, or an anion mediated reaction. So I really don't know which method was used to make this particular polystyrene. It could be any one of those 3 methods. 2 of those need, well, they all 3 really need an initiator. So we went through the reactions, but that's getting pretty deep in the weeds. Like I didn't ask anything about the individual mechanisms really in the homework questions. So that's probably a little too deep for the exam. Like I couldn't tell you if polystyrene is always polymerized with a cation reaction or a free radical reaction, because it just depends on the end result that the company that's making that polymer wants to achieve. Yeah. Do y'all feel a little more comfortable? Okay, let's go do it. All right, I'm gonna cut the video off right now. Last question?